Okay, this video concerns solving equations with rational exponents. As you can see in both of these examples, the exponents, or you can call them the powers, they're fractions, and rational is just another name for fractional. So as is the case for all equation solving, we're going to try and isolate the variable x or whatever variables in the equation, in this case x, and we're going to do things in a certain order. When there are items that are being subtracted or added to the variable, it's best to get rid of those first. So we're going to add 12 to both sides. That's going to leave us with 4x to the 9/2 is equal to 12. So 12 will be gone here. It'll be over here now. Next, we're going to remove this multiplier. So we're going to divide the multiplier right off of the variable x. So it'll go away on the left-hand side, leaving us with just x to the power 9/2. And over here, we'll have a 3. Last of the 3 steps is that we're going to try and remove this power. And let me make this a little bit lower just so it actually looks like a power. We're going to try and remove this power. And the way that you're going to get rid of fractional powers, or what they call rational exponents, is you're going to raise to another power, and that power will simply be the reciprocal of this. So you're going to raise to a power of 2/9. Don't forget that whatever you do to one side, you must do to the other side as well. If you recall, raising a power to a power, that's called the power to a power rule, and that rule goes like this. Just remind you real quick, when having a base that has a power already and you're raising it to another power, you just multiply the powers. That being said, you're going to be multiplying top times top, which is 18 over 18 again. So 18 over 18 now gives you a power of 1 once you multiply these powers using the power to a power rule. So what you end up with is x to the first degree. So perfect. That's exactly what we wanted. Now, in order to get this done, I want to remind you that anything that has a fractional power like this is actually a radical. So you're going to be taking a root. When we have a radical, we are taking that specific type of root. So you need to be reminded about how to write that in radical form. And you also need to be reminded of this. There are different kinds of roots. There are square roots, fourth roots, sixth roots. Whenever the root is an even number, like a square root, a fourth root, or a sixth root, you will report both the positive and the negative root. Even roots have 2 different roots, a positive and a negative root. When the root is odd, there is only one root, the positive root. So it will be in your best interest to be able to identify when it is an odd root versus an even root. When you are in fractional exponent form, just look at the denominator. And if it's an odd number, then you're going to be taking an odd root. And this might shed some clarity on that. Let's go ahead and write this in radical form. Okay, this is how fractional exponents get written in radical form. This big base is still the base. The 9 that you see on the bottom is the kind of root. So you see you are taking an odd type of root. The square stays right here. Now, sometimes you can go further at this point. If you were able to take this root of this base right now, like sometimes you'll be taking a square root and there'll be a 16 here and you'll actually be able to take the square root of that base number right there. That gets thrown on at the end. But here you can't actually go any further. So when you can't actually take this root of this base number, you can leave it in this form right here. So you could actually give this as your final answer. X is equal to 3 to the 2/9. Whereas, and there's only one root, again, because this is an odd root, you will only report the positive root. It is odd because of the denominator. When we wrote it in radical form, I was saying that you couldn't go any further, but yet in the next example, you'll see where you can go further. So let's go ahead and do this one. This one, there are no multipliers. There's nothing being added or subtracted on the outside of the parentheses. So we actually can't get into any of these items in here. until we remove the power. So in this particular problem, we'll get rid of that rational exponent first. So again, always to get rid of these fractional type of powers, that just takes raising it to a power that's the reciprocal. Power to a power rule says that we really multiply these powers to do that. So it's 6 over 6. So this new power becomes a 1. So it's x minus 4 to a power of 1. And whenever the power is 1, you can just remove the parentheses at that point. Don't forget that since we raised to a power of 3/2 on the left, then you must raise to a power of 3/2 on the right. Look at the bottom number. That tells you what kind of root you're taking. You are taking an even root. Therefore, you must report both the positive and the negative root when you go to give your roots. If you can't see that you're taking roots, maybe writing it in radical form will remind you of that. Okay, here's again a review of how you write this number in radical form. The base is still the base. It's called the radicand now. The number that you see on the top is the power that stays attached to that base, and the 2 is the kind of root that you're taking. So you're taking a square root, and that is an even root. So you must report both the positive and the negative root. Okay, we're not going to forget that. Now see, once I write this one in radical form, you actually can go further here. You can actually take this kind of root for this number right in here. Our base became our radicand, and we can actually take a square root. This is the shortest way to get this all done. Just take the square root of this number. Square root of 81 is 9, and then you can reattach the 3. And then x minus 4, just drop that down. You can go ahead and get your calculator to assist with that 9 to the 3rd power. And if you put that in your calculator, that's going to be 9 raised to the 3rd. That's 729. So plus or minus 729. Don't lose those. Don't lose the plus or minus. And now continue solving. You're always trying to get all the way to the point where the x is by itself. So now we're going to add 4 to both sides to finish this problem. So it's positive 4. We just added 4 to both sides, plus or minus 729. So one of the answers is 4 plus 729, or 733. And the other answer is 4 minus 729, or negative 725. And that completes the 2 problems from section 1.6b.